All right. Somebody said 4, 5, and 6. Okay.
5, 6.
Why did you almost time it?
Because I don't want to. All right, number 4. It says that the cylinders are similar, of course, and it tells you that the volume of the large one is 64 and the volume of the small one is 8. So here is the whole thing that we're trying to get through to you with these. If you know the ratio of the volumes, what do you do? Melissa?
Cube root it.
Cube root it.
Okay,
so 64 cube rooted is 4, and 8 cube rooted is 2. Okay? And so what that means is, if the ratio of the volumes is 64 to 8, that means the ratio of all of the sides, and in this case the radii and the circumference and whatnot, are 4 to 2, which reduces to 2 to 1. So now it's easy, because if the radius of the small cylinder is 10, that means the radius of the big one must be 20. Because this tells you that the big one's dimensions are twice as big as the little one.
It's good to talk to you, but I do it
All right, number 5. This should be super easy. Okay? Corresponding heights of 2 similar cylinders is 2 to 5. What is the ratio of their volume? What do you have to do? Cube them. So 2 cubed is 8, and 5 cubed is 125, and that is it. Right? Now, the only one that was legitimately challenging on this worksheet was number 6, because this mixes up volume and surface area. It says, a rectangular prism aquarium, we mean just like a regular aquarium, holds 64 gallons of water. A similarly shaped aquarium holds 8 gallons of water. So my first question to you is, if the big one holds 64 gallons and the small one holds 8 gallons, what is the ratio of the volumes of the fish tank? 4/2? No, sir. What? Close. Farther. What? 1 to 8. You just have to be difficult and do the other way, like east 4 to 1, east 2 to 1. Okay, 8 to 1. Because 64 divided by 8 is 8, right?
Jared.
Okay, so the ratio of those two things is going to be 8 to 1. Okay, now that's the ratio of the what?
Of the gallon tanks.
Of the volume. Okay, so just like we did on number 4, if I know the volumes and I want to find the ratio of the sides, what do?
Cube root it.
Cube root it. So 8 cube rooted is 2, and 1 cube rooted is 1. Okay, so this is the ratio of the volumes, and this is the ratio of the sides. However, this is why this is a tricky problem. It says if a 1.5, wait for it, square foot cover fits on the smaller tank. So they're asking us to work with the ratio of the what? Areas, because they said square feet, so they're talking about areas. So if the ratio of the sides is 2 to 1, what's the ratio of the areas? 4 to 1. Is that what you said in the beginning, Anthony? So you got cut off? Yeah, right. Okay. Yeah. So,
would it just be, couldn't I just do it the way I did it? Way easier.
Okay, so the ratios of the areas is 4 to 1. So that's going to tell us to set up a little proportion. It says if a 1.5 square foot cover fits on the smaller tank, so does my X go on the top or the bottom? Top, because I know the smaller tank is 1.5, so I'm trying to find the surface area for a cover of the bigger one. Cross multiply and divide, and X equals 6 square feet. Is that what you got?
You just told me to like cube root it like 64 and 8, and then you just square that.
Right.
And then do the proportion.
Yeah. All I did differently here is I reduced it before I cube rooted it. Okay?
Either way works.
Yeah, either way's fine.